Hello and welcome to another session in the Spark series. So in this tutorial or in this video, we will look at Spark window function. So these are basically the functions that are used to calculate results such as the rank, the row number, and some other the row number, the dense rank, and the lead lag, something that you might have seen in your SQL databases like Oracle. So the same things we can calculate this here. So what this does is basically it is going to divide or partition the data over a range, and then based on that partition it can apply these functions, the window function, and it can give you the result. So we'll look at some of them here with an example. So we are going to use the same bank transaction data for this. So I'm going to quickly execute this data, and we'll look at the data once first, and then we will see what functions or what window functions that we want to apply on this. So this is the data that we have. Okay, so the first thing that we want to do is, so we want to apply, or we want to let's say partition this data, right? So there are different columns that we can partition. So let's say customer ID. So first we will partition the data based on customer ID, and then we will apply this window functions over there, right? So in order to apply this window function, we will need to import a library. So I will have to say import org dot Apache Spark SQL. We have to say expressions, and from this expressions we have to import windows. All right, okay, so the first thing that we have to do is we have to create a window specification. So this is basically what you want to do on what partition that you want to create, right? So we want to create a partition, we want to partition data based on customer ID. So the first thing that we will do is we'll create a part window specification. So we'll say window spec, then window dot, we have to say partition by, and what is the column name that we want. So you can see multiple column names, but let's just take the customer ID. So we are basically partitioning on customer ID, and you have to give some order by, so on what you are ordering this. So let's say you can give the same column, but let's take customer account balance, right? So we will take the customer account balance. All right, so this is our window specification, and so let's go ahead and apply some functions, right? Window a function. So this is the data frame, and I'm gonna create a new column, and I'm gonna call it as row num. All right, and I want to apply the row num function. Okay, so what row num does? So row num function will give the sequential row number starting from 1. So what, so here is a customer ID, this is what we partition by. So once you partition based on customer ID, right, so what it will do is it is going to give the row numbers, right? So it is going to give the based on this order by. So the least for the same customer ID, the least customer account balance, because this is basically you're ascending, right, by default. So the least customer account balance will have the first row number, and then second row number, and so on, right? So the function that we will use here is we have to say row number, right, and dot over, and then here you have to give the window specification. All right, so okay, so we will first execute this. So I will do a simple dot show, right, and first let's execute this first, and then we will see this data. So I am going to, okay, let it be, let me just execute this. All right, so we have this data here. So You can see here the row number, all of them. So we have 1 and 2 here. So let me do one thing. So instead of selecting all the columns, let me just select few columns that are totally required for this. So if we require more columns, we can add it at a later part. But for starters, I just want couple of columns here. So one column is obviously is my customer ID and my customer account balance, because both of them are used in my Windows spec, right? Okay, so we'll start with this and let me execute it. So we will start with this. If more columns are required, we will select from the select using the select transformation or select method. All right, so this way it will be easy for us to understand how this functions, right? Okay, so if you look at this, right, row number, all of them are so most of them are one. That is because we have only one record here, so there is nothing to partition. But if you scroll here, if you look at this data, so we have two records with the same customer ID, and one is given as one, second the other is given as two. That is because your customer account balance, so this has less customer account balance, so it is going to have a row number as one. This will have a row number 2 because it has more customer or more customer account balance. Similarly, we have one more record where we have the same customer ID, and this, so this looks okay. So this is where the problem is, right? So this is again something that we need to understand. So this is, if you look at this has more, this is basically having more number, but then if you look at the row number that was given, it's basically says this is less than this, which is not the case. Now why is this happening, right? So this file, when if you do a print schema, all of them will be shown as a string. So let me show that. So let me do a print schema here. So if both of them are string, basically it will go by the ASCII word, right? So that is why you are seeing in some conflicts there. So we will need to convert that to an integer. So all of them are string, right? So because all of them are string, so your ascending and descending are basically happening on the ASCII value of the string. Okay, so we need to convert this, right? So we need to convert this to a data type, or maybe a double, or long, right? So let's convert this to a double. So here, so I'm going to use the column here. All right, so I will use a call, and here I will use cast, and the data type that I want to use is let me convert this to a double. All right, so if I execute this again, now this time it should treat this particular column data, right? So now if you see here, right, so we have the data in the right order. Okay, so this here if you see, this is 10,000, this is 12,000, and this is where we had the issue, right? So now this is sorted. So we have the data in the proper order. Okay, so moving ahead, so this is what your row number does. All right, so there is one more thing which does similar thing, so which is basically the rank. So what rank also does is it will provide a rank or a number to the result within the window partition, right? So when there are ties, what it will do is it is going to leave a gap. For example, let's say we have two customer IDs and the account balance is same, then both of them will have the rank as 1, but then there won't be rank 2. Then its record will basically be rank 3. So that's what your rank does. There is one more function which is dense rank, which does exactly what rank does. But in case there is a tie, let's say the two customer IDs are same, what it will do is it will give both of them as rank 1, but then the next record will have rank 2, so it will not going to skip that. Okay, so let's apply those as well. So I'll use with column here, and I will call it as rank, and here the rank function, I'll say rank dot over what over the window specs, which is this one. All right, and similarly I can copy this here, and I can give a dense rank, right, and this should be dense rank. So let me execute this. So because we have such a huge data, we may not be seeing this ranks and dense rank value for all of them. So here you can see all of them are basically the dense rank and rank are same. So we are not able to find the difference here. So what I can do is I can let's try a few things. So I can use a where clause, and let me do something where I can say dense rank, dense rank may be greater than 5. Okay, so some filter conditions, we are applying some random filter conditions, right? So we just wanted to find out if we have certain data where the dense rank or the rank is greater than 5. So obviously that means that you will have at least 5 records having the same customer ID. Okay, so we got some, so we have some data. So let me change this. So what I will do is column of dense rank, and I will see if this column is not equal to. So this is what we have to use, not equal to, and I want to find if there are data where the dense rank and your rank are not same. Okay, so let me save this and execute this. So we are trying to find if there are any columns where any customer IDs where we can spot the difference between your dense rank and your rank. Okay, so we have quite a few of them. So let me pick one of them. So this is, I'll pick this particular customer call ID. So now what I'm going to do is I am going to check, I'm going to change my where condition, or let me just comment this out, and I'm gonna say where column, so this should be equal to this value, and the column that I want to check is customer ID. So I am looking for the customer ID where this is the value. All right, so let me execute this. So these are some of the testing tips that you can do. So if you find a similar situation where you have huge data, but everything looks similar, you don't see any difference in the code, and you want to test them. So this is one of the ways. So try different things where you are expecting different data for different columns. So look, check for the not equal to, bring out this data, identify the unique ID or the custom or the ID that you want to check, and then filter based on this ID, right? So here we have the customer ID. So these are the customer account balance, right? If you look at the row number from 1 to 4, and if you look at the rank, right? So what rank does is, again, you are ordering by customer account balance, so the least customer account balance comes first. But if you look at this, right, so this is rank 1. If you look at the second and third record, both of them are equal. So both of them will have the same rank 2. And because these two have occupied the rank 2, there is no rank 3. So directly we have a rank 4. Suppose if we had 3 records with the same rank, then you will have 3 records with rank 2, then there won't be rank 3 and rank 4. There will just be rank 5, right? So that is what rank is. Dense rank, if you look at this, you have 2 records with the same rank, so both of them are given, but it is not going to skip the next rank. So instead of going to 4, it is going to give you the dense rank, which is the next rank number 3. So that's the basic difference between your rank and your dense rank. If the rank is same, if both of them are same, if there is a tie, dense rank is not going to skip anything, it is going to continue with the next number, next rank. But rank is going to basically skip that number, right? And it will give you the next rank. So that's the basic difference between your rank and your dense rank. All right, now we will use the same customer economy. We'll keep the filter as it is, and then we will try different window functions. Okay, and we'll also do something called as percent rank. So percent rank returns the percentile ranks. Okay, so this is another way of getting the ranks. So it basically returns the percentile rank of rows within a Windows partition. And let me do that. So with column, okay, so let's have this where clause at the end. So I'm gonna say with column, right? And the column name that I want to give is let's say percent rank. Okay, and the everything would be same here. So I'll just copy this here, and instead of dense rank, I will change this to percent rank. All right, okay, and the next window function that I want to do is lag and lead. All right, so what lag function does is it returns the value that is, you know, some rows before the current, whatever number you specify, it is going to return the value that is that many rows before the current value. And if you don't find any rows before that, it will give you as a null. Lead, on the other hand, returns a value that is the rows that you give, some rows after the current row, and then it will be null if it is less than the offset. So we will understand this with an example. So let me first quickly write this code, and again I will use a with column way to create a new column here. I will call it as a lag, and this is a little different here. So I will have to use a function called as lag, and I need to specify the column on which I want to add. So I want to use customer ID, and then the second argument I have to pass is number of rows, right? Okay, which will be 1. And of course you have to use this window function. So I'll say over, and this is a window specific. All right, so how lag does this? So basically if you look at this customer ID, right? So if this is a first record, so I have given lag of 1. So this is number of rows is 1. Okay, so basically from here it is basically going to give me a record which is before this. Now there is no record before this, right? So it will give me null. So in this is a current record, so it is going to give me a record before this, which is this record. That is how your lag works. Lead will basically gives me a record in advance, so that is your lead. So I know, once we'll execute this program, then we will understand, we'll have little more clarity. So for now I'm just going to copy paste here, and I'm going to change this to lead. I'm going to keep it as 1 column only. The number of rows is 1, so I'm using the lead, and let me execute this first. So once I execute it, once we have this data, it will be easy for me to show you how this lead works, right? We have already seen rank and dense rank, percentile rank also in the same similar lines. All right, so let's wait. Let me take this a little bit up. So this is how your percentile rank works, right? So percentile rank basically returns the percentile rank of the row. So and if you look at lag, right, on the customer ID, so we have applied this lag on the customer ID, right? So that's why you're seeing all the same customer ID, we have filtered it. So let's apply this for something else, right? So let me apply this for customer account balance. So this is different, right? So let me apply this for this, and then it will be easy for us to validate. So let me execute this. Let me take this bit up. So we have the schema printed. The next thing is the data. Okay, so so now the data is a little bit better, right? So the first thing is lag. So this is the current record, right? So what lag will print is, from the current record it will go an offset, like the offset here is 1 number of rows, that is your number of rows. So here we are saying from the current record you print the data which is one row before that. So what is one row before this? There's no row, right? That's why you have null. So when you come to the second one, right, second record, now in the second record, what is the account balance before this one row? So before this one row, this is the account balance 6520, that is what you see here. Same, if you go here third record, so this is the current value. What is the value before this? This is the value. If you come here, what is the value before this? This is the value. So that is what you see, that is your lag. Lead is basically returns a value which are before the, after the current row, right? For example, if you look at this record, right, what is the date record after this? So this is 16,406, that is what you see here. For this record, what is the data, what is the after this, after this record? So this is the data, so that is what you see. And if you go at the last, this is the current record. What is the record after this? There is no such record, that's why you see null. So that is how your lead and lag work. All right, okay. So other things that we can do with the window function is we can basically do basic aggregations, like you want to do the average, you want to find the average of customer account balance of you, or you want to find the maximum account balance, or you want to find the minimum account balance. You can do that in the windowing function as well. So let's do that. So let's keep this filter condition as it is. So I'm gonna say with column, and first I'll find out average. So I'll say average account balance, and I have to use average function, and I have to pass the column customer account balance, right? So let me copy this. I will pass it as customer account balance, and of course you have to say over and give the partition which is the window spec, right? So we have to give this. Okay, so similarly what I will also do is I will do for maximum, and I'll also do for minimum. So let me quickly copy both of them, and the only change here is the instead of average I'm going to use maximum, rest of them are same. Similarly, instead of average here I am going to use minimum, the rest of the data or the code will be same. So I will save this, and I will execute this. So this way you can also find, you can partition the data based on a column. In our case is this customer ID, and then you can do some aggregations as well for the partition data. So we are trying to find the maximum account balance, we are finding the minimum account balance, we are finding the average account balance as well. So these are the statistics we have: the average account balance, the minimum and maximum account balance, right? So this is about the Windows function. I hope this was clear, and I will see you guys in my next class.